Hi, it's Mrs. Golding, and we're working on our Friday paper 36, which is due on May 14th. So I'll tell you which section I'm in. So this is the week 3, set B, so the bottom of the first page. Given the expression below, if p equals negative 3/2, which is the smallest subset containing the value of this expression. So we've done a few of these in class, so I'm hopeful that you're pretty solid on it. We have to first solve this, right? So 8, p would be 8 times negative 3/2. And so we'll put that over here. 8 and 2 have a factor of 2 in common, so 2 divided by 2 is 1, and 8 divided by 2 is 4. 4 times negative 3 equals negative 12. So we're trying to find which subset that is in. So is it natural? Can I count it on my fingers? Nope, it's a negative, right? So the negatives fall into the integer range. So it is an integer. The next question is that the smallest subset? Meaning, what else is it contained in? So all integers are rational, right? So it is rational, but the smaller subset is integers, okay? So the next one is so we're going to go to the next set, and that is going to be this set right here. So I'm going to get you started on there. We have to obviously use order of operations, right? So 4 to the third is 4 times 4 times 4. So that's 16 times 4, 64, plus 7 times whatever we're going to get in this mix, okay? So the parentheses, within the parentheses, there's an exponent. So that's 144 minus 9. And then that divided by 5, okay? So 64 plus 7, 144, 43, 42, 41, 40, 39, 38, 37, 36, 35. 135 divided by 5. And then what is 135 divided by 5? 27. So 64 plus 7 times 27. All right, so I'm going to leave you this to finish. So take 7 times 27 and add that to 64, and you'll get your answer. Okay, so then let's go down a little bit further. So this is week 4, set B, which is the bottom of the second page, which could be a possible value for x in this expression. So 9 times something plus 4, and we're taking the square root of that. So when we're given all these values, we can just start trying them, right? So the square root of 9 times 4 plus 4. The square root of 36 plus 4. Is that going to be a square root? So, or a perfect square, I should say. So we want to get a rational number, okay? So all perfect squares are rational. So we're trying to find numbers that are perfect squares. So this is the square root of 40. Is that a perfect square? No. 36 is, but not 40. So it's not going to be that, right? So then you're just going to follow that process along till you get a perfect square. So the square root of 9 times 13 plus 4. You're trying to see what that is, right? So you have to actually do 9 times 13. So 9, 10, 11. And then 117 plus 4. And I want you to see if that's a perfect square. And again, you're going to try all of these until you get to one that is a perfect square, meaning something times itself is that number, and whichever one is perfect is what you're going to go with. I know some of you, I can hear Haley yelling at me right now saying, "You're not finishing these. You didn't finish it." And I got to have you do a little bit of work on this paper, right? Okay. I didn't mean to throw you under the bus just now. I'm sorry. But you know that's what you're saying. All right. So we got to distribute here. Completely simplify this expression. But we also need to distribute here and here. So let's do that first. Negative 30c plus 12d minus 7d. Now, minus c. You see how negative 1 times c is just negative c. Or I could put negative 1c, right? So then I'm going to combine my like terms. What is this guy going to do? Let's try it out. Oh, yeah. This guy and this guy go together. And then let's make him green. This guy and this guy. Like terms, right? Okay. So now let's go back here. So negative 30 minus 1. Negative 31c. Now you're going to finish. So combine 12d minus 7d. So you're going to end up with an expression. Okay, it's not going to end up being one number, but you're going to have an expression. I gave you half of it, you finish. Okay, so is this the last one we're doing? I think it is. So this one right here, Mrs. Golding's head is in the way. Okay, so which values could be placed in the boxes if the equation has a solution of all real numbers? All real numbers. So a solution of all real numbers is what we called infinite solutions. A symbol for it is this, right? You can also have, I don't know if you guys remember my, when we were doing interval notation for a little while, this would be the symbol for all real numbers from negative infinity to infinity and beyond. Okay, so we're just testing numbers. So this for A, so negative 2 times x plus 4 minus 1 equals 5x minus 9 minus 2x. So I'm just plugging this in here. So then distributing negative 2x minus 4 minus 1 equals 5x minus 2x, 3x minus 9, and then 2x, and then negative 4, negative 1, so that's 2x minus 5 is equal to 3x minus 9. So far, it doesn't look like this one's going to be that, because what I'm trying to find is equal values, so equal expressions. So this expression is exactly equivalent to this expression, so that there's basically the same expression on both sides. So far, it doesn't look like it, because this one looks like it's going to have one solution, minus 2x, minus 2x, negative 5 equals x minus 9 plus 9 plus 9. See how this is working out? Okay, so A is not the answer, but you're going to follow that same process through B, C, D until you get to the correct answer, and you should have infinite solutions. That's the one that you want to select. Okay, so don't yell at me too much. I did have to make you work a little bit, But I do hope that this video is helpful to you. And by the way, if you're still listening, number 2, there's a big problem with number 2. So be very careful in how you answer that question. And I will see you tomorrow. Have a great day. And remember, you're important and the world needs you. And so do I.